Hey, algebra students, here we are in chapter 6, and we're going to talk about solving inequalities by addition and subtraction. I've gotten used to solving equations where we just get one simple answer, and what's going to happen here is that's not going to be the case. We're going to get a whole set of answers. For instance, if I told you that, let's see if I can get my pen to work here. If I told you that some value x plus 2 has to be greater than 3, you can kind of think about the number. There's not one answer that's here. X plus 2 has to be greater than 3. Well, 1 doesn't work because that would be equal to 3. But 2 would work, and 3 would work, and 4 would work, and in fact 1.5 would work. So there's so many different things that would work in this inequality. And so what we would do to talk about this answer is we can say the answer to this equation is x such that x is, now what kind of numbers did we realize? We realized that x had to be greater than 1, right? Such that x is greater than 1. And this is called set builder notation. When we solve an inequality and we get an answer, we would write it in a form like this. X such that x is greater than 1 would satisfy this inequality. Let me back up a minute. So that is set builder notation. So if you feel like you're cool with that, excellent. We're talking about inequalities, which means that we're using these symbols: less than, greater than, less than or equal to, greater than or equal to. And so sometimes we might even use this one, is not equal to. Inequalities literally means not equal. So set builder notation is something we primarily would use, or we learn to use at least at first with our inequalities. So let's get on to some examples. Solve by adding. The cool thing about inequalities is that they're really going to behave just like an equation. So I've got t minus 45 is less than or equal to 13. You remember how I started off teaching us about, like, put a line down the middle and do the same thing to both sides. There's laws that tell us that we can add, as long as we add to both sides of an inequality and subtract the same thing from both sides of an inequality, we preserve that inequality. Meaning, it's totally legit for me to add 45 to both sides in order to solve. And this less than or equal to situation stays the same. So I'm really treating it like an equation. T is less than or equal to 45 plus 13, which is going to be 58. So my solution will be written that this works for all t such that t is less than or equal to 58. That will be my set builder notation way of writing it. And the way I'd graph that is I would think about, okay, well, I'm concerned about the number 58, so I'm going to just do that. Put the 58 in there. So notice I'm honoring the fact that 0 on the right side of 0, we have positive numbers. On the left side, we have negative numbers. And I'm just being a little bit cheap in my usage of just putting 58 here. Sometimes you'll see people write 1, 2, 3, 4, 5, 6, 7. But we know we're looking at 58. And so I know that t can equal 58 because it says less than or equal to, or is less than 58. So if t can equal 58, I'm going to put a solid dot on 58 saying that yes, you can be 58. And then I'm going to shade in this direction, in the less than direction, to say that all the answer choices that are going to work for this inequality would be written in this way. So this is the answer. How do I check my solution? Well, you would check your solution by choosing a value that has this quality where t is indeed less than or equal to 58. So if I were to plug in, let's say 0, that's an easy number. 0 minus 45, is that less than or equal to 13? Let's check it out. 0 minus 45 is a negative 45. And the question I'm asking myself, is negative 45 less than or equal to 13? Yes, it is. So I feel comfortable if I choose answers within the set that I state as the solution. If I choose those answers and it works out, that means I've checked it and I'm good. Let's look at this next one. We're going to graph the solution. The last one, they didn't ask us to graph it, but hey, good practice. So if I graph this guy on the number line, the first thing I need to do is solve. I treat these like equations. Literally, I can add to both sides or subtract from both sides of an inequality, and nothing happens to the sign. It maintains that inequality relationship. And so what I'm going to do is add 4 to both sides. When I do that, I have 11 is less than x. Another way of thinking about that is to say that x is greater than 11. X does not equal 11. X is greater than 11. So let me go ahead and put some numbers here. 2, 4, 6, 8, 10, 12, 14, and a little -2 back here. X does not equal 11, and it is greater than 11. So what I need to do is go to 11 and put an open circle. I can't just say, oh, X could be 12 and then shade up that way, though that's kind of true, because I'd be missing all these numbers between 11 and 12, like 11.5, which would work, and 11.73298. So when I graph this, when I graph something that is not equal to, just greater than or less than, I put an open circle at the number that I'm comparing my variable to, and then I follow through by shading. So X is greater than 11 means that I'm going to shade to the right to represent all X values. And I can write that X such that X is greater than 11 as my solution set. So here we're going to solve by subtracting. Again, this is a lot like just any kind of algebraic equation that you would solve. So I'm going to get rid of the 19 because I want to isolate the r, and I'm going to add a -19 or subtract 19, however you see fit. So r is greater than or equal to -3, because -19 plus 16 is a -3. And I'm going to graph my solution. My solution is going to be -1, -2, -3, and a +1, 2, 3 right here. And I'm going to have, what do you think, open circle or closed circle? I hope you're screaming at the screen saying closed circle, because indeed the circle is closed because it says that r can equal -3 or it's greater than -3. So r is equal to or greater than -3 means that I'm going to color in the -3 because that's a possible solution, and I'm going to shade greater than that -3, and I get this answer there. Number 4, variables on both sides. Again, this is, if you know how to solve an equation, this is kind of like fun baby stuff to you. You're like, this is awesome. If you were having trouble solving equations, then this is going to be challenging, and that's something that we should talk about. So here we've got 5p plus 7 is greater than 6p. Let's move our variables over to one side. So we have a -5p. Excuse me. Like that. 6p plus a -5p is just p. So we've isolated p. 7 is greater than p, or I could say p is less than 7. When I graph this bad boy, I'm concerned with number 7 on the number line. So I'm going to just immediately go there. I'm going to have an open circle at 7, and I'm going to shade to the, well, p is less than, so I'm going to shade to the left, because that's where all the values that are less than 7 are located. Are you guys walking down my street? I'm hoping this makes sense. Let me know if it's not. So here's a little key that should be a little bit helpful for you. Inequalities, this is less than or fewer than, and this is greater than or more than. That's when you would use that, and at most. Now, what this language is giving us the opportunity to know how to apply it in word problems. And I think I gave you some word problems for your assignment. So when you hear at most or at least, recognize the symbols that you'll use. No more than, all of these phrases should be hints as to how you would write your inequality for a word problem. All right, so write an inequality for the sentence below, then solve the inequality. So we have a number decreased by 5 is at most 8. So a number, how do you decrease? By subtracting. A number decreased by 5 is at most. The highest it could be is 8. That's going to be less than or equal to 8. So it can be 8, but it can be less than that because it says it's at most 8. So once we write this, we just solve like we've been solving before. We can do the same thing to both sides of an inequality, and that inequality is maintained. So x is less than or equal to 13. If we had to graph the solution, We'd find 13 on the number line. Here's 0. We know that we're going to have a solid dot because this is less than or equal to, right? So a solid dot at 13 and x is less than, so we're going to shade to the left, okay? Let's look at this last example. Example 6, write an inequality to solve a problem. So Yulia Raskina scored a total of 39.548 points in the 4 events of the rhythmic gymnastics. Yulia Barsukova scored 9.883 in the rope competition, 9.900 in the hoop competition, and 9.916 in the ball competition. How many points did Barsukova need to score in the ribbon competition to surpass Raskina and win the gold medal? So I just organized the information. Raskina's information is here and Barsukova's information is here. And we know that she has one more thing that she needs to compete in, and that's the ribbon competition, and that's the score that we're asking about. We want her to surpass Raskina according to the problem. Therefore, we want Barsukova to be greater than that. And so this is the inequality that we would solve in order to figure out the value that she should get or the score that she needs to get in the ribbon competition in order to surpass Raskina. So that leads us to this inequality where we add up all of these numbers and get 29.699, and we need to calculate the value for r. So we're going to subtract this 29.699 from both sides, or we're going to add the opposite, however you choose to look at that. And when we do that, what we end up with is 9.849 is less than r. So we realize that she needs to get a score that is greater than r. The ribbon score needs to be greater than 9.849 in order for her to beat Raskina. And so with that in mind, I think that's all we have for examples today. Those are some guided practices. We can skip that. I hope that this didn't seem too bad. Sometimes the word problems are a little bit tricky just to kind of organize what the expectation is, because honestly we barely use inequalities when we think about word problems. That's not a typical thing. So it might feel a little unwieldy, but you'll be okay. Just try it and do your best. I look forward to seeing you and talking to you soon. Please take care, dear. Bye-bye.